Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on entropy and the second law of thermodynamics. Previously, we discussed standard states, which are reference points that can be used to calculate the properties of a substance under different conditions. We learned about standard molar enthalpy of combustion and how the heat of combustion can be used to estimate the energy that is available from different foods. We also discussed standard molar enthalpy of formation and standard molar enthalpy of neutralization. We learned how to measure standard molar enthalpy of neutralization. In today's lesson, we will explain entropy and entropy change. We will look at entropy changes using physical and chemical processes, and we will learn how to calculate the entropy from the given standard entropies of substances. Let us begin our lesson by learning about spontaneous and non-spontaneous processes. A spontaneous process is a change in a system that proceeds without any outside influence on the system. Let us look at an example. When we add salt to water, the salt eventually dissolves. While stirring the solution would speed up the dissolution process, it does not require any outside influence in order to proceed. The dissolution occurs spontaneously. Students, it is important to note that just because a process is spontaneous, that does not mean that it will occur instantly. For example, when oxygen gas comes into contact with iron metal, it causes the metal to begin to rust. However, even though this process is occurring spontaneously, it will take some time before you begin to notice it. Thermodynamics can only be used to determine the direction and the extent of a reaction. It cannot be used to determine the speed of a reaction. However, there are other processes that will not occur independently. These are known as non-spontaneous processes. Let us look at an example. Water will not freeze on its own if it is left in surroundings that are at room temperature. However, if it is cooled until it falls below 0 degrees Celsius, it will freeze. Thus, in order for the change to occur, an outside influence must be applied constantly. You may also have noticed that once a nail has rusted, the rust will not change back into iron metal and oxygen gas. Students, what is the difference between a spontaneous and a non-spontaneous process? Please give one example of each.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. You were correct to say that the difference between a spontaneous process and a non-spontaneous process is that a spontaneous process is a change in a system that can proceed without outside influence, whereas a non-spontaneous process cannot. Non-spontaneous processes require the constant application of outside influence. A ball rolling down a hill is an example of a spontaneous process. A ball rolling up a hill is an example of a non-spontaneous process because it would need some type of external action to get it started, like pushing. Great work. I am sure that you recall learning about enthalpy in previous lessons. We learned that the enthalpy change for a process is an important indicator of whether or not the process is favorable. For example, exothermic processes that have large negative enthalpy changes are often spontaneous. However, we are about to learn that we cannot just consider the enthalpy change of a process when we are trying to determine its spontaneity. We must also consider how the disorder of a system alters during the process. Entropy, denoted by capital S, is the thermodynamic property of a system that is related to its degree of randomness or disorder. If a system has a greater amount of randomness, then it will have a higher entropy. The S1 unit for entropy is joule per Kelvin. This is the same unit that is used for heat capacity. Entropy is a characteristic property of every substance, as is color, hardness, volume, density, melting point, and enthalpy. Entropy is an extensive property because it increases as the amount of a substance increases. The entropy change for a chemical change is equal to the sum of the entropies of the products minus the sum of the entropies of the reactants. In this equation, M and N represent the amounts of the individual species represented by their coefficients. Thus, a hypothetical reaction might look like this. The entropy change would look like this. S subscript A represents the entropy of A. S subscript B represents the entropy of B, and so on. After you have calculated the equation, if the change in entropy is greater than 0, then there has been an increase in randomness or an increase in disorder. If the change in entropy is less than 0, then there has been a decrease in randomness or an increase in order. Students, predict whether each of the following reactions leads to an increase or a decrease in the entropy.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to predict whether each of these reactions leads to an increase or decrease in the entropy? Reaction A leads to an increase in entropy. Reaction B also leads to an increase in entropy. Reaction C leads to a decrease in entropy. Did your answers match those? If so, great work. If not, review your notes and ask your teacher for help if you need it. In today's lesson, we learned about spontaneous and non-spontaneous processes. We also learned about entropy, which is an important factor in determining the spontaneity of a process. In our next lesson, we will discuss the second law of thermodynamics, as well as free energy and free energy change. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.